Hello everyone, I want to use this video to go over lecture number 2. In this lecture, we are going to learn the nature of geographic information or GI. So in this lecture, you are going to learn the following three components. The first one is the 4 aspects of geographic information and the examples. Number 2, very important in GIS, we are going to learn how to define map scales, how to do the calculation. What is a large map scale map and what is a small scale map and what's the difference. Number 3 is spatial autocorrelation and the first law of geography. Okay, and let's get started. So this is our entire knowledge structure of GIS. In GIS, we basically learn 1, 2, 3, 4, 5 things. We start from here, data representation. And in order to understand what kind of data we can put in GIS, we need to know the nature of our data, right? So that is the purpose of this lecture. Okay, so why geographic information is special? I always say spatial is special. Geographic information make itself stand out, or it's because it have the location component. Okay, where it is. That is the geographic information. But not just that, at that location, we are also interested in the thematic attributes, thematic information. So what's that? For example, in Los Angeles County, right? This is location information, how large the population is. That is the thematic attributes of LA County, right? In Texas today, how many people get affected by COVID-19, right? So that number is the thematic attributes of Texas in this case. Okay, so geographic information, you must have those two components, location plus thematic attributes. As you can see later in our lectures, in GIS, when we represent geographic information, we need to record location. That is the need to learn coordinate system. And we store our thematic attributes in some data formats. For example, tables. For example, Tableau, as some of you are very familiar with, right? So those two information you must have when you define geographic information, okay? In addition to that, we have two optional components. One is called time. Some geographic information we care how it changes over time. For example, the intensity of Hurricane Ida, right? Over time it changes. And spatial topology what's that? Note, it's not topography. Topography is the shape of the terrain. Topology is the relationship between different features on Earth's surface. So for example, I can give you one, for example, one is the relationship between Santa Monica main campus and Pico. What would you say? You probably say, oh, the main campus is on Pico, right? So you use on to describe the spatial relationship, relative location between Pico Boulevard and Santa Monica College, the main campus, right? Okay, so what's the relationship between Broadway, the strait in Santa Monica, to ocean, to our Pacific Ocean? Well, Broadway ends in ocean, right? The end of Broadway is our Santa Monica Pier. Okay, so you can see that is topology. Topology describe the relationship, the location relationship between different spatial features. Okay, so that is the four aspects of geographic information. As you can see later, when we represent our data, let me go back. When we represent our data in GIS, sometimes if those two are really important, we need to represent in our data model too. Okay, we need to find a way to represent time, how things change over time, and how spatial topology change over time. Okay, so if you go, oh, it's a different link. Let me just remove it. It doesn't matter. Okay, so here's my examples over here. Okay, so you can see location, longitude, and latitude, but it's just one way to describe location. Okay, and thematic attributes. In most GIS software, we use tables. We use tables to represent, so you can see one row represent one location, okay, and different column represent different attributes, thematic attributes, okay, and spatial, the time, usually we also use tables, okay, and topology is a real challenge. It's a real challenge. Well, some data model you can define that, some data model you cannot. Later we will learn how they are different, okay. Alright, so those two you must have. Okay. So location. Okay. The location description in the GIS system, you need to meet some requirements. So that's also why we want to use coordinates. Okay. So what are the requirements? Number one is the location description need to be unique. Okay, so you can see, well, the main street actually is not a very good way to describe location, because you can see how many cities in United States we have this main street. I know in Madison, Wisconsin Madison, we have a main street. Santa Monica, we have main street. Probably many places have main street, right? So it's not unique. It should be shared. What does it mean shared? It means everyone understand where it is. So for example, if you are in Santa Monica, you say Main Street, Earth Cafe. People know it, right? But outside Santa Monica, people may or may not know it. Okay, so those name actually is not perfect to describe location. Okay, and need to be constant, cannot change. Well, believe it or not, our census tract change a lot. Okay, sometimes they just redraw the census tract, the boundary, and the election precinct also change a lot, right? Okay, so that is not a good description of location and need to be numerical. Okay, so that is why in lecture number 3 we need to learn coordinate systems. How to define x and y on our surface. Okay, well, longitude and latitude is one way, but it's not the only person in town. We have other ways to use numbers to describe location, pinpoint location on our surface and maps. Okay, so here is a geographic joke. This is a place on Earth. Check this link where it is. I won't give it away. Okay, so in that town, we have two streets, actually three streets. We have this street, we have that street, we have the other street. So if you call your friends you living there, they will say, oh, I live on this street. You probably will be very confused. What is this street? What is that street? Right? So you can see here the naming, the location information is not perfect for GIS because it's not unique, it's not shared, it can be changed, and it's not numerical. Right? Okay, so spatial topology studies the geospatial relationship between geospatial features or objects, for example, points, lines, and polygons. Okay, so you can see in this case, you can say, well, California is along is to the west of Nevada. Okay, it's along the west coast of United States. Okay, so you can see in the sentences you describe the location information. Okay, and in this case, this is the map of LA. You can say, well, Dodger Stadium, that is the geospatial objects or features, right? It's to the north, okay, of High Freeway 110 freeway. Okay, it's to the north of downtown. Okay, so you can see we use those sentences to describe the relative location information, right? Okay, so that is the spatial topology. Okay, here is a few rules or a simple example of geospatial relationships between objects. Okay, so you can see point and point. You can say it's within or it's near, next to. Okay, and point line, for example, Santa Monica College, right? It can be on the line or nearest to the line. Okay, and point and area relationship, or can be that point is inside this polygon or on the boundary of that polygon, right? And line, you can be intersect, cross, flow into, like our Broadway to Ocean Avenue, right? Okay, and then line and area, you can intersect or it's a border. Okay, area and area, you also have overlap, inside or adjacent to, next to, neighbors. Okay, so that is simple rules or simple relationship defined in GIS. Okay, we make the complicated spatial topological relationship simple. Okay. Okay, so how about thematic attributes? We know that is like attributes of spatial features, right? So here we can classify those attributes into two types. It can be qualitative or quantitative. Okay, so here different times. Okay, you may hear people say it's nominal, ordinal, interval, or ratio. Well, nominal just means name. For example, this state, its name is California. That is a nominal information. Okay, we have different, cities. For example, Los Angeles, San Diego, San Francisco, right? Okay, that is a nominal information. Okay, we can also have ordinal information. What's that? That is orders. Okay, so for example, the largest city in California is where? I think it's LA or San Francisco. I'm not quite sure. Okay, but we can sort our cities by population. right? And number 1, number 2, number 3, that is the ordinal information, okay? And interval, that is difference. So for example, San Francisco, the annual precipitation every year, the rain they received is this much inches more than Los Angeles, than San Diego. Okay, so you can see that is the interval information. We emphasize the difference. The last but not least, ratio. Okay, so for example, all the precipitation here, the absolute number, and the climate, the temperature, okay, and population, they all ratio information. Okay, so qualitative. You can do mathematic calculation using this information. Okay, so you can see one place actually we can have a lot of thematic attributes, and each of them will fall into one of those 4 categories. Okay, in our table, we need to store all these types of thematic information, and later you will see we use different format. We use different format of that column to define those information. Okay, later you will see that. Okay, data types basically can be string, right? Can be a quantitative number. Okay, that we are talking about the the field attributes. Okay, the field formats. Okay, all right. Okay, so this is ratio, nominal, ratio, and nominal. Okay. All right, time. Things change a lot over our surface. Okay, so you can see this is a meandering stream. Geologists know this, right? And we form over time. We form this. It's called oxbow lake, like the ring on the nose of your bulls, right? And here is a change of migration in United States. Percentage of U.S. African American population change over time. Okay, and this is one person, her daily routine in her city. Okay, and you can also click on this living atlas of the world I shared with you last time. Okay, you can see how things change on our surface. So for example, this should be Las Vegas, I think. Yes, this is Las Vegas. And now we are looking at 2021 data. 2021 data. Oh, it's actually more interesting to see Lake Mead. Okay, August 2021 is like this. Okay, and how about here, last month? How about we go back, all the way back to 14. Okay, do you notice the changes? Okay, and the city also have significant changes. So this is 2014. This is 2014 as well. Let's go to 15, 16. Let's go to the side a little bit. Maybe you can see the changes. Ah, this one is different. This one is different. This one is also different. See? See here, that lake. Okay? And you can see the ground change a lot. Okay, 2019 changed a lot. How about now? Okay, yeah. So you can see, you can also download those save that to your ArcGIS Online and to do the analysis, to analyze how things change over time. Okay, so this is our nature of our geographic information. Okay, and map scales. Okay, so map scales actually determine the spatial coverage and the level of details of the map. Okay, so this is how we define map scale. That is the distance you measured with your ruler on the map. For example, 1 inch represent this over this line. We read it as represent how many miles on the ground. Okay, but when you do this calculation, this is actually the ratio, which means you need to convert the distance on the ground from miles, from kilometers, to the distance, to the unit you're using with your ruler. Okay, like inches, centimeter. So that is why you always see this ratio is very weird. Okay, but actually it's very simple. It reads every 1 inch you measured on the map represent 24 this many inches on the ground, and you can convert it to miles or kilometers. Okay, you can also say 1 inch equals to 4 miles. You can use this graph to represent, okay, this green bar right here represent 10, whatever it measures on the map. This long represent 10 kilometers on the ground. Okay, so many ways you will see that a lot on your topographic map, for example. Why it matters? Small scale, large scale, they give you different level of details. For example, small scale is zooming out. So you can see here I'm showing you the entire lower 48 state. In terms of, well, thematic information here, that is population by race, okay, racial groups. Okay, but when you're zooming in large scale map, you can see LA, but here LA just like this very crowded cluster, right? But when you're zooming in, you see more details about that place. In this case, Los Angeles. And then you can see Los Angeles, different people where they are, right? So here, click on this link, you will see this awesome map. Okay, let's go to Los Angeles. We have Los Angeles here. You can search. Here is entire United States. Los Angeles right here. Okay, and you can see we can zoom in and even to Santa Monica. Now we are having a larger map scale. When we zoom out, that is a smaller map scale. Okay, but you can see when you're zooming in, you see more details about this area. Okay, and here, go to the link, go to the legend. You can see when you hover over, you can see different people where they are. Okay, so in our meeting, let's have more fun about it. Okay, so last but not least, the spatial autocorrelation. Okay, Tobler's laws of geography. That is the first law of geography. Okay, well, it's actually very easy. It's everything related to everything else. Okay, but near things, if the two places are very close to each other, they're more similar than distant things. For example, in this case, temperature. Okay, Florida temperature is very similar to, for example, Georgia. Not that similar, right? But for sure, Florida temperature is very different from Minnesota, right? Okay, so that is the first law of geography. Okay, here, why we want to learn this? Why this matters in GIS? Because it gives us a lot of advantages. Okay, we can use this law. We can use this law to guess what's nearby. So, for example, you know for example, elevation of this spot. You can sort of estimate the elevation at all these spots, right? Or you have all this spot, you can estimate, for example, soil moisture at this location. Okay, we call that spatial interpolation. For example, here across the United States, lower 48, we only have a few, not a few, those dots actually are the weather stations, as you can see here, right? Okay, but why on the weather channel, for example, we have the temperature map cover the entire lower 48, you don't have those gaps, right? So for example, here in Nevada, we don't have any weather station. How do we know the temperature here? As about 80, between 80 and 90s. You can see in this color. That's called spatial interpolation. We basically use the nearby weather station, the data, the measured data, to guess what's the temperature over here. Okay, so that's called spatial interpolation. Okay, later we will learn how to do that with GIS. Okay, but keep in mind, the first law of geography, you can find a lot of violation examples. So what's that? Near things are more similar to distant things, right? Well, how about this? You stand over on the top of this cliff. Well, the next thing to the cliff actually is our ocean. It's totally different, right? Okay, and you can see here in this case we have the basically the loss of the soil and the loss of the vegetation, right? In this space you have grassland, you have crops, but next to it it's just this barren land. Okay, even landslide over here. Okay, so there's another violation of first law. I would encourage you to find your own examples, okay, when you take the quiz. Here, I give away the last question of your quiz, okay? Think about in our geographic space, what else violate this first law of geography? The near things are more similar to each other. Okay, so I believe this is the last slide of this presentation. Okay, and we learned three things: the four aspects, location, thematic attributes, time, and topology, spatial relationship, right? And make sure you can give examples. Map scales, what's the small scale, what is large scale? Small scale, zooming out, you see less details, you see more general information. And when you're zooming in, that is a large scale, right? Why? Because this definition, because the distance on the map when you're zooming in represent shorter distance on the ground, right? Shorter distance on the ground. Well, then this ratio becomes large. So that is a map scale. Last but not least, that is a spatial autocorrelation that allow us to guess what's at that location by using the nearby stations, right? Okay, and the first law of geography and the violations. Okay, all right. So that is this lecture. I'm looking forward to learn more, to dig into deeper with you in our class meeting. Okay, bye for now.